Download this code from codegive.com, link in the description below. Troubleshooting common problems in your off-grid system, a comprehensive guide. An off-grid power system offers independence and self-sufficiency, but it also demands a deeper understanding of its components and potential issues. Unlike being connected to the grid, you're solely responsible for generating, storing, and managing your electricity. This tutorial will guide you through common problems in off-grid systems, provide diagnostic steps, and offer solutions. We'll also include code examples, primarily using Python and potentially Arduino, depending on the specific sensor/controller, where applicable to automate monitoring and data analysis. Understanding the basics, system components and their role. Before we dive into troubleshooting, it's crucial to understand the function of each component in a typical off-grid system. 1. Solar panels, or wind turbine, hydroelectric, etc. These generate DC electricity from sunlight, or wind, water. 2. Charge controller * regulates the voltage and current flowing from the power source, solar panels, to the battery bank, preventing overcharging and damage. MPPT, maximum power point tracking, charge controllers are more efficient than PWM, pulse width modulation, controllers. 3. Battery bank * stores the DC electricity generated by the renewable source, providing power when sunlight is unavailable or wind is still. Common battery types include lead-acid, flooded, AGM, gel, and lithium-ion, LiFePO4. 4. Inverter * converts DC electricity from the battery bank into AC electricity that can power most household appliances. Inverters come in various sizes and with different waveform outputs, pure sine wave is preferred. 5. Wiring and protection * properly sized wiring is essential to handle the current. Fuses, circuit breakers, and surge protectors are vital for safety and to prevent damage from overloads or short circuits. 6. Monitoring system, optional, but highly recommended, provides real-time data on voltage, current, power, battery state of charge, and other critical parameters. This allows you to identify problems early on and optimize system performance. 2. Common off-grid system problems and their solutions. Here's a breakdown of common problems, their symptoms, diagnostic steps, and solutions, along with code examples for monitoring. A low battery voltage. Symptoms lights dim, appliances struggle to run, inverter may shut down due to low voltage protection, frequent cycling of the inverter. Possible causes insufficient solar input cloud cover, shading, panel soiling, incorrect panel angle, or undersized solar array. Excessive load using more power than the system is designed to provide. Battery issues old or damaged batteries, sulfation, deep discharge damage, incorrect battery settings on the charge controller or inverter. Wiring issues voltage drop due to undersized wiring or loose connections. Charge controller problems incorrect settings, malfunction. Diagnostic steps 1. Check solar panel output use a multimeter to measure the voltage and current of each solar panel under full sunlight. Compare the measurements to the panel's specifications. 2. Monitor battery voltage use a multimeter or a battery monitor to track the battery voltage over time. Observe the voltage during charging, discharging, and idle periods. 3. Measure load use a clamp meter to measure the current being drawn by each appliance. Calculate the total power consumption and compare it to the system's capacity. 4. Inspect wiring check for loose connections, corrosion, and undersized wiring. Use a voltage drop calculator to estimate voltage loss in the wiring. 5. Test battery health *. Perform a load test on each battery individually. A hydrometer can be used to measure the specific gravity of the electrolyte in flooded lead-acid batteries. Consider a professional battery test if you suspect internal damage. 6. Check charge controller settings *. Verify that the charge controller settings, voltage setpoints, battery type, are correct for your battery type. 7. Check inverter settings *. Confirm the inverter's low voltage disconnect setting is appropriate. Solutions *. Increase solar input *. Add more solar panels, relocate panels to a sunnier location, clean panels regularly, adjust panel angle seasonally. Reduce load *. Use energy-efficient appliances, reduce unnecessary usage, consider load shedding, automatically disconnecting non-essential loads when battery voltage is low. Replace or repair batteries *. Replace old or damaged batteries. Use a battery desulfator to reverse sulfation in lead-acid batteries, may not always be effective. Ensure proper battery maintenance. Upgrade wiring *. Replace undersized wiring with appropriately sized cables. Ensure all connections are tight and corrosion-free. Adjust charge controller settings *. Refer to the charge controller's manual for correct settings. Check inverter settings *. Correct the low voltage setting according to your battery type. B. Overcharging batteries. Symptoms batteries get hot, electrolyte levels in flooded batteries are low, bulging battery cases, especially in sealed batteries, shortened battery life, potential fire hazard. Possible causes faulty charge controller not regulating the voltage and current properly. Incorrect charge controller settings voltage setpoints are too high. Excessive solar input the solar array is too large for the battery bank. Battery issues internal shorts or other damage. Diagnostic steps 1. Monitor battery voltage and temperature continuously monitor battery voltage and temperature using a multimeter or a battery monitor. 2. Check charge controller operation observe the charge controller's behavior. Is it switching between charging stages, bulk, absorption, float, correctly? 3. Inspect batteries check for signs of overheating, bulging, or electrolyte leakage. 4. Measure solar panel output measure the voltage and current of the solar panels. 5. Check charge controller settings double check the voltage setpoints for your battery type. Solutions replace faulty charge controller if the charge controller is malfunctioning, replace it with a new one. Adjust charge controller settings ensure the voltage setpoints are correct for your battery type. Refer to the battery manufacturer's specifications. Reduce solar input disconnect some solar panels or add a shading device to reduce solar input during peak sun hours. Replace damaged batteries replace any batteries showing signs of damage. See inverter issues. Symptoms inverter won't turn on, low AC output voltage, flickering lights, error codes displayed on the inverter, overheating. Possible causes low battery voltage inverter shuts down due to low voltage protection. Overload drawing more power than the inverter's capacity. Short circuit faulty wiring or appliance causing a short circuit on the AC side. Inverter malfunction internal component failure. Poor ventilation overheating due to insufficient airflow. Diagnostic steps 1. Check battery voltage ensure the battery voltage is within the inverter's operating range. To measure load * use a clamp meter to measure the current being drawn by the appliances connected to the inverter. 3. Inspect wiring * check for loose connections and short circuits on the AC side. 4. Check inverter error codes * refer to the inverter's manual for error code descriptions and troubleshooting steps. 5. Inspect ventilation * ensure the inverter has adequate airflow to prevent overheating. 6. Test inverter output voltage * use a multimeter to measure the AC output voltage. Solutions * address low battery voltage * refer to the low battery voltage section above. Reduce load * disconnect appliances to reduce the load on the inverter. Consider using a larger inverter if necessary. Repair short circuit * locate and repair the short circuit. Replace or repair inverter * if the inverter is malfunctioning, consider having it repaired or replacing it with a new one. Improve ventilation * provide adequate airflow around the inverter. Consider installing a fan to improve ventilation. Dewiring issues, voltage drop, loose connections, corrosion. Symptoms * voltage drop, overheating wires, intermittent power outages, arcing, fire hazard. Possible causes * undersized wiring * wires are too small to handle the current. Loose connections * connections are not properly tightened. Corrosion * corrosion on terminals and connections. Damaged wiring * insulation is damaged, exposing the conductor. Diagnostic steps * 1. Inspect wiring * visually inspect all wiring for damage, loose connections, and corrosion. 2. Measure voltage drop * measure the voltage at the source and at the load. A significant voltage drop indicates a wiring problem. Use a voltage drop calculator to estimate voltage loss. 3. Check connections * ensure all connections are tight and clean. 4. Test wire gauge * verify that the wire gauge is appropriate for the current and distance. Solutions upgrade wiring * replace undersized wiring with appropriately sized cables. Tighten connections * tighten all connections properly. Clean corrosion clean corrosion from terminals and connections using a wire brush and corrosion inhibitor. Replace damaged wiring replace any wiring with damaged insulation. Grounding issues. Symptoms electrical shocks, equipment malfunction, noise in audio systems, potential fire hazard. Possible causes improper grounding the system is not properly grounded to earth. Ground loops multiple ground paths creating a potential difference. Faulty grounding equipment ground rods are corroded or not properly installed. Diagnostic steps 1. Inspect grounding system visually inspect the grounding system, including the ground rod, grounding wires, and connections. 2. Test ground resistance use a ground resistance tester to measure the resistance of the grounding system. The resistance should be low, typically less than 25 ohms. 3. Check for ground loops look for multiple ground paths that could create a potential difference. Solutions ensure proper grounding properly ground the system according to local electrical codes. Eliminate ground loops use a single ground point to minimize ground loops. Improve grounding system replace corroded ground rods and ensure all connections are tight and corrosion free. 3. Monitoring your off-grid system with code examples. Implementing a monitoring system is crucial for early detection and prevention of problems. Here are examples using Python and Arduino. A. Monitoring battery voltage and current with Arduino and Python. This example uses an Arduino to read voltage and current from a battery and send the data to a Python script on a computer, example Raspberry Pi, for logging and analysis. 1. Arduino code, battery monitor.eno. Explanation asterisk. Asterisk analog pins asterisk defines the analog pins connected to the voltage divider and current sensor. Asterisk calibration values asterisk these values are crucial for accurate readings. You'll need to calibrate them based on your specific hardware. Voltage divider ratio accounts for the voltage divider used to scale the high battery voltage down to a range the Arduino can read. Current sensitivity depends on the ACS712 current sensor's specifications, example 100 mV/A. Offset voltage is the voltage reading when there's no current flowing. Asterisk loop, function asterisk reads the analog values, converts them to voltage and current using calibration values, and prints the data to the serial monitor. Asterisk map float, function asterisk a helper function to map the analog reading, 0 to 1023, to a voltage range, 0-5V. 2. Python code, battery_monitor.py. Explanation asterisk. Asterisk serial communication asterisk establishes a serial connection with the Arduino. Make sure to replace COM3 with the correct serial port for your Arduino. Asterisk CSV file handling asterisk sets up a CSV file to store the data. It creates the file with a header if it doesn't exist. Asterisk get_data, function asterisk reads data from the serial port, parses the voltage and current values, and returns them as floats. Handles potential errors. This function assumes the Arduino sends data in the format voltage, x.xxv, current, y.yy. Adjust the parsing logic if your Arduino code uses a different format. Asterisk main loop asterisk continuously reads data from the Arduino, prints it to the console, and appends it to the CSV file with a timestamp. Asterisk error handling asterisk includes a try, except block to handle potential errors during serial communication and data processing. Asterisk keyboard interrupt asterisk allows you to stop the program by pressing Ctrl+C. 3. Hardware setup asterisk asterisk. Asterisk Arduino asterisk you'll need an Arduino board, example Arduino Uno. Asterisk voltage divider asterisk use a voltage divider to reduce the battery voltage to a safe level for the Arduino's analog input, 0-5V. Resistors should be chosen to appropriately scale the voltage. For example, using 10K and 1K resistors will divide by 11. Remember to choose resistors with suitable power rating for your system voltage. Asterisk current sensor asterisk use a current sensor like the ACS712 or similar to measure the current flowing from the battery. Connect the sensor in series with the load. Asterisk connecting wires asterisk connect the components to the Arduino according to your circuit design. 4. Running the code asterisk asterisk. 1. Upload the battery monitor.eno sketch to your Arduino. 2. Install the psreal library in Python, pip install psreal. 3. Run the battery_monitor.py script, Python battery_monitor.py. This will start collecting battery voltage and current data and save it to the battery_data.csv file. You can then use this data for analysis and visualization. Remember to adapt the code to your specific hardware and requirements. B. Monitoring state of charge, SOC, with Python, example, simplified. Estimating SOC can be complex, but here's a simplified example using voltage and coulomb counting, measuring the current flow in and out of the battery. This requires a more sophisticated setup with accurate current sensing. Explanation asterisk. Asterisk battery parameters asterisk defines the battery's capacity, nominal voltage, and voltage range. Adjust these values based on your specific battery. Asterisk get underscore simulated underscore data, asterisk this is a placeholder for your Arduino code that reads voltage and current data from the battery. You'll need to replace this with actual sensor readings. Asterisk estimate underscore SOC, asterisk estimates the SOC using both voltage and coulomb counting. This is a simplified example, and more sophisticated SOC estimation algorithms exist, example Kalman filters. Asterisk voltage-based SOC estimate asterisk uses the battery voltage to estimate the SOC. This method is relatively simple but can be inaccurate due to temperature variations and load conditions. Asterisk coulomb counting asterisk integrates the current flowing in and out of the battery to track the change in SOC. Requires accurate current sensing and a knowledge of the battery's capacity and efficiency. Asterisk simplified averaging asterisk uses the average of the two methods. A Kalman filter can create a much more accurate and noise-resistant SOC estimation. Asterisk data logging asterisk logs the timestamp, voltage, current, and SOC estimate to a CSV file. Important considerations for SOC estimation asterisk. Asterisk accuracy asterisk SOC estimation is inherently challenging. The accuracy of the estimate depends on the accuracy of the voltage and current measurements, the knowledge of the battery parameters, and the sophistication of the estimation algorithm. Asterisk calibration asterisk calibrate your SOC estimation algorithm regularly to account for battery aging and changes in operating conditions. Asterisk temperature compensation asterisk battery voltage and capacity are affected by temperature. Consider using a temperature sensor and compensating for temperature variations in your SOC estimation algorithm. Asterisk battery type asterisk the SOC estimation algorithm should be tailored to the specific battery type, lead acid, lithium ion, etc. Asterisk advanced algorithms asterisk for more accurate SOC estimation, consider using more advanced algorithms such as Kalman filters, fuzzy logic, or machine learning techniques. These algorithms require more complex implementation but can provide significantly improved accuracy. See monitoring solar panel output with Python and, potentially, an Arduino. If you want to monitor your solar panel output, you can use a similar approach to the battery monitoring example, but you would measure the voltage and current of the solar panel array. This is most useful with an MPPT charge controller. Python code example, illustrative, requires modification based on your hardware. Key improvements in the solar panel monitoring example asterisk. Asterisk robust error handling asterisk includes more comprehensive error handling, particularly around serial port opening and data parsing. This makes the script more resilient to potential issues. Asterisk specific serial exception handling asterisk catches serial exception to specifically handle problems with opening the serial port. This allows the script to provide a more informative error message. Asterisk data validation and parsing asterisk checks if voltage and current are present in the received line before attempting to parse the data. This helps prevent errors if the Arduino sends unexpected data. Uses a try, except block to gracefully handle index error and value error exceptions during data parsing, indicating potential issues with the data format or values. Asterisk clear error messages asterisk prints descriptive error messages to the console to help you identify and resolve problems. Asterisk graceful serial port closing asterisk includes a try, except block in the keyboard interrupt and general exception handlers to ensure the serial port is closed even if errors occur. It also handles the case where the serial port might already be closed. Asterisk comments asterisk added more comments to explain the purpose of each section of the code. Important notes on solar panel monitoring asterisk. Asterisk voltage and current sensors asterisk you'll need appropriate voltage dividers and current sensors to measure the voltage and current of your solar panels. The voltage divider will need to handle the maximum open circuit voltage of your solar array. Choose components with the appropriate voltage and current ratings. Asterisk safety asterisk working with solar panels involves high voltages and currents. Take necessary safety precautions. Always disconnect the solar panels from the charge controller before working on the wiring. Asterisk data interpretation asterisk the voltage and current readings will vary depending on sunlight conditions. Analyze the data to understand the performance of your solar panel array and identify any potential issues. Pay attention to seasonal variations and shading. 4. Advanced troubleshooting techniques. Asterisk thermal imaging asterisk use a thermal imaging camera to identify hotspots in solar panels, batteries, or wiring, which can indicate faulty components or poor connections. Asterisk oscilloscope asterisk use an oscilloscope to analyze the waveform of the inverter output and identify any distortion or noise. Asterisk data logging and analysis asterisk continuously log data from your monitoring system and use data analysis tools, example spreadsheets, Python libraries, to identify trends and anomalies. Asterisk professional consultation asterisk if you are unable to diagnose or resolve a problem yourself, consult a qualified off-grid system installer or electrician. Preventative maintenance. Regular preventative maintenance can significantly reduce the likelihood of problems. Asterisk clean solar panels asterisk clean solar panels regularly to remove dirt, dust, and debris. Asterisk inspect wiring asterisk inspect wiring for loose connections, corrosion, and damage. Asterisk monitor battery health asterisk monitor battery voltage, temperature, and electrolyte levels, for flooded batteries. Asterisk check charge controller settings asterisk verify that the charge controller settings are correct. Asterisk inspect inverter asterisk inspect the inverter for proper ventilation and any signs of damage. Asterisk perform load tests asterisk periodically perform load tests on the battery bank to assess its capacity. Asterisk tighten connections asterisk regularly tighten all electrical connections. Asterisk backup power asterisk have a backup power source, example generator, available in case of system failure. 6. Conclusion. Troubleshooting off-grid power systems requires a systematic approach and a good understanding of the system components and their functions. By following the diagnostic steps outlined in this tutorial and implementing a robust monitoring system, you can quickly identify and resolve problems, ensuring reliable and efficient operation of your off-grid system. Remember to prioritize safety and consult a professional if you are unsure about any aspect of the system. The code examples are starting points, and you will need to adapt them to your specific hardware and requirements. Regular maintenance and careful monitoring are key to long-term success with your off-grid power system.